Okay, today we are going to start our revision for the course. And here we started with, first of all, what is the objective of traffic engineering? The primary objective for traffic engineering is safety. Then speed, comfort, convenience, economy, all of this comes next as a secondary objective. But as I mentioned, the primary objective is safety. As we studied, for example, in intersections, our objective is to develop phases where conflicting movements are not allowed to move together. Okay. Then we go to what are the main component or the main elements of traffic systems. We said that we have traffic road users, vehicles, infrastructure, traffic control devices, environment. Then we started discussing the road users, and we said what's the key important issues or characteristics for road users. So we discussed the visual characteristics, okay, vision, and we mentioned that why vision is important, because drivers rely on vision in detecting hazard, making turn decisions, selecting acceleration, deceleration. All driving tasks are made based on vision. Okay. And we discussed the different types of visions. We have visual acuity, static visual acuity, dynamic visual acuity, movement in depth, and so on. And we discussed the vertical field of view, okay, or the field of vision, vertical, and that was the schematic showing what's covered in the field of vision example, and the horizontal field of vision, and the binocular field of vision, and the peripheral field of vision. And we mentioned that there is a great impact for speed on the visual field. As we mentioned, okay, could you just mute your phone? Okay, as we mentioned, with speed, the field of vision start diminishing. Okay, and that's an example at a 24 kilometers per hour. That should be the field of vision. When we increase to 35 kilometers per hour, it reduced to 40 kilometers. That's to 48 kilometers per hour. That's for clear vision. Okay. Now, why? How can we utilize the field of vision information? Field of vision information used by traffic engineers to in the placement of traffic signs on the highway, and in determining the traffic sign size, and also in safety analysis. Then we discussed the perception reaction time, and we said that perception reaction time is basically two components. It's a perception time and reaction time joined together. Okay, the perception time is defined as the time it takes the driver to sense and perceive and understand the existence and nature of a stimulus. Reaction time is basically the time that the driver needs to make a decision, not to excuse. Could you just mute your speaker, Mr. Okay, sorry about that. So, as we mentioned, we have perception reaction time, and the reaction time is basically the time it takes the driver to take a decision on how he is going to react, how he or she is going to react to the stimulus he's seen. Okay, then that was a schematic to explain how the process of perception, it goes from the sensory phase to the integration phase to the perception in the visual cortex of the human being. Okay, then the decision-making phase, it comes from the cortex, okay, to the thalamus, okay, to the orders to motor muscles, then starting to the execution phase. Okay, so these are the two phases. As we can see, the perception time and reaction time basically depends on the neural connectivity between the sensory organs and the peripheral nervous system. That leads us to how these are impacted. Okay, so basically what the factors that affect the perception reaction time are basically age, fatigue, okay, complexity of the situation, and presence of alcohol or drugs in the driver's body, because basically it affects the neural connectivity in the human body. Also fatigue affects the neural connectivity. Age affect the processing time, okay. Complexity of the situation also affects the processing time. uh, the recommended design values for perception reaction time are 2.5 seconds for most computation involving braking reactions, that's based on ASHTO, and 1 second for signal purpose, based on the Institution of Traffic Engineers. And basically, 1 second, because basically drivers, when they are approaching traffic signals, they understand that there is a chance it's going to turn from green to red. And here, that's the expectancy, okay? And you see that the cross, that's the perception reaction time, okay, on surprise, and if they are surprised or alerted or braking. The perception reaction distance, which is basically the distance elapsed, okay, during the perception reaction time. And this is varied by speed. As the speed increase, okay, the perception reaction distance is increased. Okay, then the second component for road users was, or the other characteristics for road users, we discussed the characteristic of pedestrians. And for pedestrians who are interested in the walking speed, so we can set up the crossing, the minimum pedestrian phase time. And the studies show that we have a 4 feet per second recommended intersection for recommended intersection design. This covers the 15th percentile speed, which can be converted in the metric units to 1.22 meters per second. For gap acceptance, okay, so that's for pedestrians crossing the streets, and we found that the 85th percentile gap acceptance was 37.5. The other issue with the comprehension of control devices, flashing don't walk, how people comprehend it. Then the second part, or the second characteristics we discussed, was the vehicle characteristics. In vehicle characteristics, we divided the vehicles according to ASHTO into 4 major categories. The first category was the passenger cars and the buses, trucks, and recreational vehicles. So when we talk about passenger cars is a wide category that includes all passenger cars, sedan cars, SUVs, okay, are considered as passenger cars, minivans, okay, vans, small vans, pickup trucks, all of these are considered as passenger cars, okay. Buses, okay, buses starts from small buses that can take maybe 24 passengers and more. This is considered as a bus. A minivan is not considered as a bus, okay. Trucks from single unit trucks, tractor trailer, and tractor semi-trailers these are trucks. But for example, if you are talking about a Ford F-150, okay, this is not a truck. This is an SUV or pickup truck, okay. Why? The criteria here is basically the horsepower per ton, okay. And as you can see, for example, Chevy Silverado, okay, Chevy Silverado or Ford 150 or F-150 or Dodge Ram, these SUVs or pickup trucks, basically, if you the proportion between the engine horsepower and the vehicle total weight is high. It's similar to just a passenger car. But trucks, we're talking about trucks that are 7 tons and above. That's truck. The last category, which is recreational vehicles. What do we refer? What can what does this category refers to? It refers to motorhomes, camping campers, okay, motor campers, cars with various types of trailers. For example, a passenger car that is towing a trailer, a boat trailer, or a motorcycle trailer, a trailer that is carrying a motorcycle or something like that. This is considered, okay, an RV. Why RV? This one, it occupies, first of all, a large portion of the road, okay, and its rate of acceleration and deceleration is similar to a truck or bus, okay. So it ought to be treated differently than a passenger car. Okay, vehicle turning characteristics. Of course, for these categories, the turning characteristics are totally different. Okay, so we have two turning characteristics. We have the turning characteristics, slow turning, and the high speed turning. The high speed turning, we can apply the equations for designing horizontal curves. And for the slow turning, the geometry is key in design in this design. The minimum turning radius and this stuff, that's key. That's a key issue. But for high speed turning, we have this equation for the horizontal curves, and this is the simplified version of the horizontal turning speed, where S, that's the turning speed in meter per second, G is the gravitational acceleration, R, the radius of turn, FL, that's the side friction, okay, E is super elevation. In cases of intersections, for example, the super elevation would be 0, but in designing a horizontal curve, it will have a value. The super elevation, okay, this is just for designing a horizontal curve. And that's the coefficient of side friction, okay? As you can see, as the speed increase, it decrease. It's not like a longitudinal friction. The longitudinal friction for stopping, it's 0.345 or 0.348, something like that. So we use it basically to determine the speed of turning at intersections or roundabouts. That's in this course. But for the highway design, we use it for designing horizontal curves. And the other characteristic, which is the stopping characteristic for the vehicle. And we discussed this, the generic unit equation, okay, where the distance stopping equal the initial speed multiplied with the time, perception reaction time, plus the difference between the initial speed and the final speed squared, okay, divided by 2g, that, okay, and the F here, that the coefficient of friction, pavement friction, that's the longitudinal friction, not the lateral friction or the side friction. And we had an example on an accident reconstruction, okay, and we had these problems. Then we mentioned the vehicle power characteristics, but we didn't talk about it much in this course because it's important for highway design, not for traffic primarily, for designing climbing lanes and stuff like that. Then we discussed the application of vehicle characteristics on traffic light application, okay? And we said that we use the stopping side distance or the stopping distance in determining the yellow time, okay? Where the yellow time equals the stopping side distance divided by the approach speed plus the passing speed divided by 2, okay? Where, and also the all red time, okay, the clearance time basically is the passing distance plus vehicle length divided by the passing speed. And here, that's for a through movement, case, the stopping side distance divided by the approach speed. Because basically the passing speed in this case is basically the approach speed. And the all red time, okay, is the passing distance, which is the road width or the passing width, plus the vehicle length divided by the approach speed, which is basically the passing speed. But for the left turn, okay, for turning movements, the passing speed is different, okay? And here you see how we can get the V turning. So the stopping side distance is divided by the approach speed plus turning speed divided by 2. That's the average speed, okay? So the stopping side distance divided by V plus VT over 2. And that's the V turning. We get it from this equation, okay? And the all red is basically the passing distance plus vehicle length divided by the passing speed, okay? So we, in calculating the clearance time, we see the speed of turning, that's the passing speed, okay? واضح النقطة دي يا شباب للكل؟
واضح ان شاء الله يا دكتور.
Okay, in calculating.
هذه بالثرو يا دكتور ها؟
This is for the through movement. This is for the left turn
movement.
Okay.
Yes.
And we had an example here how to determine the yellow time and the all red time. Okay. Then, now we are done with the road user characteristics and the traffic stream, the vehicle characteristics. Now we have to study the traffic stream characteristics. And in the traffic stream, we need to differentiate between two types of traffic stream. We have uninterrupted traffic stream and interrupted traffic stream. Okay, what is the uninterrupted traffic stream? That's a traffic flow, that's a traffic facility, okay, where there is no endogenous interruption for the traffic flow. No exogenous, I'm sorry, no exogenous interruption for the traffic flow. If there is any interruption for the flow, it's endogenous, it's from the traffic itself. Okay, بمعنى يا شباب ان ال uninterrupted تمام مفيش اي interruption للفلو خارجي، ممكن بيكون من الترافيك نفسه، من السيارات نفسها هي اللي بتعمل interruption. Okay, but for the interrupted traffic stream, this is let me just see something. Okay. Okay, we'll take a break soon, inshallah. Now, so that's the uninterrupted and interrupted. Okay, we're going to take a break and come back, inshallah, after 5 minutes, okay?